we're going to have a recording for folks to be able to come in and watch and then participate. Can we mute folks that are being noisy maybe? If you could try to mute your computers, those of you that are logged in, we're getting a little bit of feedback noise.
Should be good.
Okay, can you advance to the next slide, Connor? Oh, maybe we'll just do quick introductions. Most of you probably know Connor. He's usually sitting at the front desk. Is great at taking money and other things. You've got Seth here. I think everybody knows Seth, and Renee. Renee, in the back row, with the rest of the troublemakers. Okay, so here's our agenda today. 2 to 3 o'clock is kind of just this general refresher. This is the mandatory part where we're going to talk about the reg changes and things that we're seeing out there in the field. Then 3:30 to 4, we'll go into kind of a questions and answers session. That part, if you guys leave at that point, we're going to release you, no more guards at the doors. And then from 4 to 5, we're going to have a little bit of a deeper dive into the design components of the reg changes, mainly the soils changes. There's a lot of changes in there, really digging into soils, especially around R-type soils or rocky type soils, whether it be fractured bedrock, deteriorated bedrock, cementation of the soil. And while it's good awareness, we're going to talk about it. We're not going to get into a lot of detail until that 4 to 5 session. So I'm going to do most of the talking between 2 and 3 with Renee helping me. He's our staff geologist. He's going to talk about the soils briefly. And then Seth is going to be primarily leading the 4 to 5 o'clock. Advancement here. So what are our objectives today? One is to prepare for the 2026 season on us. And then 2 is become familiar with the new regulation. Advance, please. If that controller works, I could try that.
Just plug it in. Give it a shot.
Yep. So why do we need a new regulation, right? Jim and I were just talking earlier. Where'd you go, Jim? We were talking about how it's now over 200 pages, right? I've been here for 22 years. I think it was around 50 pages when I started. Most of you guys remember that. I don't like having such a big regulation, but I think this regulation really does address all of the unique characteristics of our state and the geology in our state, hydrogeology in our state, small lots, big lots, rural. And so when people go, well, your regulations don't address my situation, every time we make an advancement, I think they do address some of those unique situations. For the most part, if you've got a standard soil and a big parcel flat, you can still put in a pretty traditional system. A lot of you may not even know that all systems don't have to be engineered, but most of ours are, and primarily it's because we live in a difficult county, right? All the easy lots have been built for the most part. So our primary objective is to protect public health and environment, of course. Then we need to align with State Reg 43. Our last reg revision was in 2018, so it's been a little bit. We're probably due for an update. You guys all know some of our 2018 regulation had some typos or some misdirections within it. We hopefully have cleaned up those. And then meet the financial and logistical needs of industry, homeowners, and environmental health. We are here to serve, our community, and so enabling people to build on their lots certainly is a goal of ours. Consistency with other jurisdictions. One of the main changes that you'll notice in our new regulation is formatting. And so in the past, I was pretty proud of our regulation that it pretty much followed the flow of the water from flushing it at the toilet to the sewer to the tank to the field to the maintenance to the abandonment. And so our old regulation followed that well. This one doesn't follow quite as well. Then there are some spots that talk about soils within the design portion. There's some spots that talk about soils in the planning and initial site visit section. I'm not a huge fan of that, but what I am a fan of is consistency. If you can't be right, be consistent, right? And so this regulation will look a lot more like what you see in other counties because we align the formatting with the state format. And then again, it's kind of repetitive, align reg format to state reg 43. Next, oh, here we go, I got it. Think.
Maybe. Check.
Is yours not going either?
There we go.
Okay. Interesting. So here's kind of that format change that we talked about. The table of contents is here, and you can see.
Doesn't work on TV.
It doesn't work on the TV. Great. Anyway, you can see in that 43.4, all of the administrative stuff is pretty much in that chapter. And so you talk about permitting, enforcement, variance procedures, use permits, operating permits, penalties. Those are all in that section. So that's a pretty heavy section. And then you get into kind of the site preparation, design, and then it does kind of a little bit follow the sewer to tank to field to abandonment process. Doesn't look like the batteries are all. So on our website, hopefully a lot of you have seen this. This was a kind of an AI generated summary of the substantial changes to the regulation. This isn't all of them, of course, but we'll start with this and then we'll get into a few one-offs that aren't included in this list. So we talked about the regulation format. The next thing is there's a few definitional changes, and you got to kind of keep in mind that the perspective here is changes from Reg 43, not necessarily changes from what we had last year. So a few of these things you'll go, well, that's no change from what we've been doing in Summit County, but it is a change from Reg 43. And this definition of covered transaction versus title transfer was kind of changed a little bit to align the terminology with statewide practices. And we still have a definition kind of what a title transfer and a covered transaction is within our regulations. We specifically exempted transactions between immediate family. And so in the past, I think it had from spouses, and we were honoring like a transfer between siblings, but that wasn't really codified. So we put that into our regulation. Use permit terminology. State regulation has acceptance document. We call it a use permit. You guys that work in other jurisdictions have seen that. We're keeping the use permit terminology. Easements, this is a new one. So some of you have worked on properties where you have to put the soil treatment area on a neighboring property, and because the subject property is too small, so we get an easement written up. A lot of times the homeowner will write that up, aka our attorney, because the homeowner doesn't really know, isn't really well versed on writing easement agreements. That's a very legally binding document. And so now our easements need to be written or reviewed by a licensed attorney. So that's definitely a tightening of the screws there. Agreed, but I think it was necessary. Winter installations. Those of you that were involved in the stakeholder review process, I really appreciate your input on this. What we proposed and got approved by the board is that we're not going to allow installations of on-site wastewater treatment systems that are part of the underground portion, the construction portion, after December 1st until April 30th. We did add here without prior approval, okay? So we know that there are situations where this should be occurring. It's a failing system, for example. I forget what the other situation was that we talked about, but we have some allowance. Think about sand installations after like October 1st. You know, we want you to call us and be like, or can I do this sand? I need an extra inspection. We want this to be more strict than that, but it's not a hard and fast rule. We just want to limit installations because we've seen homeowners in particular, homeowners in Florida, homeowners in Texas, they have no idea what our winter conditions typically are. And they're pushing you guys to do installations in January when the soil is frozen, you're out there shoveling, you can't properly bed it well, right? And so then we're out there doing inspections, we're freezing, looks good to me. You didn't get out of your car, Dan. I know, it's cold out there. And so it's just not a good idea to install the below ground excavation portion in those months. And so that passed, and to my surprise, a lot of you, or almost all of you that provided feedback, were supportive of that because you guys are getting pushed by homeowners. And feel free to raise a hand and ask questions anytime during this presentation. Design flows, back up one, good. Design flows, additional design flow added with more than 2 sleeping spaces per bedroom. So, hey, think about how we design septic systems. How does the public think we design them? Bathrooms, right? How do most of you think we design septic systems? Bedrooms, right? I would argue it's not bedrooms. So then you might argue, okay, it's people. I would argue it's not people, it's actually flows, right? And so we're really concerned with how many gallons per day that septic system is going to be receiving. And so we need to design our system for that and soil type, right? Those are the 2 variables. So a lot of times we're looking at a house design and we're doing a bedroom count and we see 4 bunk beds in a bedroom. Should we be designing that for 4 people or our paradigm of 2 people for that bedroom, right? Our regulation has kind of limited us to designing that for just 2, even though they're clearly communicating they intend to put 4 people in there. Go to the next slide, please, Connor. Where did you find this, Seth? Was this a real house in Summit County?
Oh, yeah.
Yeah. So this is kind of a living room or whatever you want to call this area here. And they've got a hallway. They've got 4 bunks built in the wall of the hallway, right? So the regulation was written for us to be able to count that as 4 people. Not because we want to be mean or nasty or complicated, but because they're clearly communicating they want to pack a bunch of people in there as a short-term rental. Not a problem if you design for it. Next slide, please. ADU flows. This was an enhancement to the state code. It's not really an enhancement to our code. If you have a 4-bedroom primary house and an accessory dwelling unit that has 2 bedrooms, we're going to design for 6 bedrooms. Okay. The state kind of clarified some of that, but I feel like we've always been pretty clear on that. Gravel specs. This is one that's come up for a couple of reg revisions. What the state rules say since 2014, I believe, is that the leach field or soil treatment area gravel needs to be between a 1/2 inch and 2.5 inch. Correct me if I misspeak on any of this because I mix up the numbers sometimes. Between a 1/2 inch and 2.5 inch. What have you guys typically used? 1.5 inch washed rock, right? So what does this come to mind? Another type of rock that you could potentially use between a 1/2 inch and 2.5 inch. Washed rock. Potentially 3/4 inch rock that's very well washed, okay? And so the washed is the key. So if you reach out to your gravel pit and you say, do you have any washed 3/4 inch rock, okay? Don't just go ahead and buy it. I wanna see the sieve analysis on that to kind of make sure that it meets the definitions that we're expecting here. Because it doesn't have an allowance for anything below a 1/2 inch, right? But washed, even in a well-washed sand, you're gonna have what, up to 3% fines. So in a sieve on this rock, you're probably gonna have a few fines in there. But I'm curious what a well-washed 3/4 inch rock looks like. And so if you're proposing that, your engineer's okay with that, get a sieve analysis and we can evaluate that. But theoretically, you can use a washed 3/4 inch rock, okay?
Are you requiring us to get the sieve before we use 3/4 washed rock?
So no,
Okay.
we're gonna walk up on site and go, this rock looks really small. Do you have a sieve analysis for this? And then you pull a sieve analysis after the fact and it doesn't pass, you're gonna have to pull the rock out. Does that answer your question? So yeah, we're not requiring.
So yes, you do have to turn one in before you put the 3/4 in.
Yeah. Property line setbacks. This is gonna be an interesting one. This is a big shift. Our regulations have always had 10 feet, right? The new regulation at the state, and we adopted it because I like to be consistent with the state unless we got something compelling that's different in the high country. So you can go as close as 3 feet. 3 feet on a property line setback. All right, let's just design systems for 3 feet, right, Rob, Matt? No, you can't just design systems for 3 feet. The way the language says is if you have to, if there's no other way, if your only next step is a variance, then you can potentially encroach on that property line no closer than 3 feet. The weird language in there is it talks about you can't impede your neighbor's ability to develop their property. So that's interesting. Anytime you're encroaching on their property line, now their well is gonna have to be another 7 feet, right? So that's gonna be a little interesting. But it's a last resort.
You guys still have to issue a variance at the local level.
I don't think
I thought
so.
that was the way it was written. So no longer does the variance have to go to the state level, it can now be handled at the local.
Are you talking about a well to STA setback?
No, the property line setback, but reduction.
I don't think there's a statewide variance, but well, this is why we're talking. I don't remember any language sets on it. He's gonna look into that. If there's something in there, that's why we're talking. I don't remember a variance language being in
The
there.
idea was to make it a lot easier, but you still have to go through the check. So we have to, as a designer, we have to provide justification
Yeah,
and proof of all those things you just mentioned in order for you guys to issue.
It's consistent. I think it's consistent with variance procedure, right? You've tried to make a conforming system, you tried to maximize setbacks, but you're unable to. And so you kind of met those conditions of it without having to be presented to the board to grant said variance.
Awesome.
yeah, we'll review it. I mean, designs start with the designer designing for something that conforms to the regulation, of course. And then we're double checking that. And so, we'll be reviewing that for sure when and if it comes up. I'm sure it'll come up at some point. But you think about, we can give administrative variances without the Board of Health for a failing system with some tight guardrails. Might be something like that, but I'm not remembering that. We'll double check. Groundwater separation. So we've got varying groundwater separation distances. For a pressurized soil treatment area, it's 3 feet. Then for higher level treatment, you can encroach up to 2 feet. One of them is 2.5 feet, different things. But we can actually encroach within a foot or up to a foot if you have a disinfection system. We've never had that in Colorado, I can recall. So yeah, it's called, you've got a TL1 effluent, you've got TL2, 2N, TL3, TL3N. Now we've got TL3ND. Okay, so that's the highest level of treatment now. TL3N with disinfection. That disinfection would typically be UV, or what else am I thinking of? Disinfection. Usually not chlorine is not the preferred route. I can't remember if that's allowed or not. Ozone. Yeah. So the problem with chlorine is you're injecting a chemical into your soil treatment area where your bugs are hopefully thriving. On the other hand, TL3ND is pretty much treated. Almost drinking water, a surface discharge standard, right?
Inspectors taste a sample outside.
Yeah, well, yeah, it'll just drink it. I mean, some people will say, I'll drink the water, 2 feet below your infiltrative surface, because your pathogens are usually gone in 2 feet, but I would not take that dare. So, plus you could run out of chlorine, right? A UV system has a pretty prescribed maintenance schedule when the lamps get dirty. And so it's usually, I think, a year time or something, you can come out. But yeah, and then you get the little chlorine pucks. People like to use the pool ones instead of the septic system ones, and then they blow up. So chlorine isn't ideal. Chemical toilets. The state reg allows us to permit chemical toilets. I wasn't interested in permitting every chemical toilet, and so we're not going to do that. We just specified that they need to be operated in a clean and sanitary way, Contractor exams. This is something that we changed about a year ago. Some of you are familiar with the state Part A exam. It's like 80 questions or something. So we get a call from someone who operates in Eagle County. They want to get licensed in Summit County, and they've taken this statewide test. And we go, sorry, you got to take our test too, right? A lot of people are frustrated by that. So we have adopted a policy where we're honoring that Part A exam if you already have it. And then you come in and just take a Summit County specific shortened exam. I think it's 20 questions or something like that. Just because Summit County, like any county, has some uniquenesses, and we want people still be aware of that, but it's a much shorter exam. This mandatory training, we kind of modified the language to allow folks who can't be here. I know not everybody is in Summit County today, and so they can come in and watch a recording of this meeting later and verify participation. And then finally, fees. A few fees were changed. We looked at all of our fees, and they go up every year for inflation. So our fees are really in line with the costs that we incur. But we've seen some designs that come in and we mark them up. Next slide, please. We mark them up with, where'd my slide go? Can you go one more? Maybe it's towards the end. I did an AI markup of a design, with a bunch of red lines, change this, and maybe we ask 20 things to change, and we get the design back, and the designer changed 2 things. Right, okay. Here's the other 18 things. Okay, they changed 2 more things. And on some designs, we've gone back and forth 10 times with the designer. That's not fair to the taxpayers. And so we've adopted a fee to address that. The designers and us have the other situation where a homeowner buys a house, already got a 4-bedroom septic, and they want to do a 6-bedroom septic. So they hire the engineer to do a revised design, submit it to us. We've never charged any additional fees for that unless we have to go on site. in this case, with our new fees, we'll be charging, I think it's $63 and $126 for those 2 reviews, with 1 complimentary free. Next slide, please. Gravel specs, I think we already talked about that. This picture was taken just a couple of weeks ago, where the inspector, the engineer, and the county inspector got on site and found these larger rocks. That's a 2.5-inch sieve. Clearly not all of the rock is passing that. And so the reason we put this in here is we don't like to give people that bad news, you know, to modify that system, right? And so I want you and your guys to be questioning that. And I know every one of you that's licensed and knows all the rules isn't always on site. So it's up to you to like empower all of your guys that are on site to watch for this and kind of go, this seems a little bigger than a standard 1.5 inches, right? Okay, next slide. So this is starting to get into the soils stuff. Renee, if you want to start making your way up here. This is our LTAR, long-term acceptance rate table. In the past, if you look at this, so everything in the darker gray has to be engineered design. On the right 3 columns, you can see treatment level 1, treatment level 2 and 2N, treatment level 3 and 3, and D.
I don't know about you, but I can't see this far back.
Okay.
I can't see and I'm this close.
Yeah, so not really critical. This is more of a design portion we'll get into in the next portion. But those 2 rightmost columns used to be 4. Now they're consolidated into 2. Again, not a big deal for installers, more for designers. Is the next one getting into soils more? Yeah, okay. So Renee is our staff geologist. He's got geology degrees, so he's going to talk about some of the soils information. Super. And I do want to just emphasize very quickly that we're going to get into this more in Seth's section. This isn't designed to be a section that makes everybody experts in soil. And in fact, we're still learning some of this.
Good afternoon, everyone. As Dan mentioned, soil is a science, and I just want to cover some of the basic concepts and the things that also have changed in this regulation so we can all have a common understanding. Section 5 is site and soil evaluation, okay? And then Section 10 is more about soil treatment area design. Whenever we do a profile hole, what we look at. So we always go for the soil textures. That's the first thing that we want to see, what the component of sand, silt, and clay are in this soil, so we can give it a name, right? A loam, a sandy loam, a clay. That's the primary distinctive parameters that we're looking at. The other thing that we're looking at is soil structure. All these things are things that are located in this table. Go for the next one. One up.
This one.
Forward. So as you can see, this one here, we do have next to the soil texture, which will be our classification of soil, we have a structure type and a structure grade. These things are going to be now relevant to classify the type of soil and also how we design our STA. That's why we're going to talk a little bit about it. Go ahead. Okay. So as I mentioned, soil texture, how we classify our soils. Soil structure is the way the soil particles are aggregated in the soil, the clumps, right? Whenever we grab some soil, it tends to form in different types of clumps. As you can see, soil structure, we have granular, they tend to be round, blocky, more square, more angular. Platy are the flat ones. We also have massive, when they have no structure, it's just one big block of rock. And then find the single grain, when it's just disintegrate in single grains. So I want you guys to have that awareness that besides the type of soil, we're also gonna look at how they agglomerate in nature. All right, and the last part of that one, it talks about the PED. PED is the soil aggregate. So these clumps are actually called PEDs, okay? So it's just for awareness, we're just not gonna call them soil, we're just gonna call them PEDs, which are these little soil groups. PED is composed of different types of things, right? So we have the rock component, sand, silt, clay. We have our organics in the soil. We also have water. Okay, so I want you guys to be aware that soil is composed of little different things that they stick together, and that becomes a pad. Next. All right. So as I mentioned, the soil structure is the shape of the pad. How is this pad is in nature? We can have granular, blocky, prismatic. As I mentioned, some of the basic ones, right? We have here on the right. So it depends on how we aggregate these pads in the soil, is that's how we're gonna classify them. Why it's important? Because the space between this pad is where most of the water flows through. So it's gonna help us with our retention or treatment and also our dispersal. So it's super important to be aware of these characteristics. So let's go for the next one. The other characteristic will be the grade. How distinct and stable are these pads? So when we grab from a pile of dirt, when we grab these pads, do they disintegrate? Do they stay? So that we have different grades. The structureless is there's no discrete unit. So these pads you don't really see it. You just see a pile of dirt. There's nothing really structural. Weak, we can see some of these pads. And then moderate to strong, we actually see them in place. So we can see, oh, they're round, or they're blocky, or they're plated. We can actually distinguish. And this is super important also because we can understand how this deform, and also, as I mentioned, how the water flows in between. Okay, so a characteristic that now we're going to be looking at, it will be consistency. Okay, so the degree and kind of cohesion and adhesion means how this soil sticks to each other, and also how it sticks to other things. Let's think about clay. Clay sticks to each other, right? It's very sticky. That will be cohesion. Adhesion will be how clay sticks to other things. Okay, and this is relevant because if we have this soil that sticks to each other, it's not going to let the water flow through. It's not going to permit this permeability. That's why we're going to be looking at consistency. Consistency can be either expressed as the stickiness, as I mentioned, adhesion and cohesion, and also the resistance of the soil to deformation or rupture. So how these pads behave, do they break easily? Are very hardly cemented? Are really strong? So all these factors are used to determine if the horizon will have a permeability lower than what we expect. So let's say we're thinking about a sand, usually highly permeable. But if it's a sand that is very resistant, it's very cemented, it's not going to permeate as easy. So we'll be looking at, perhaps we need to call it something else. Maybe we need to design for thinking of all the other things. Let's go for the next one. Okay, so we're talking about rupture resistance. So how easy these pads break, okay? So when we have loose, we can't really get pads. As I mentioned, it's just a bunch of soil, loose dirt, non-cemented, when you just can break them really easy, all the way down to indurated, which is really hard. You can actually hit it with a hammer, it's not gonna break. Anywhere in between, we could determine these pads. Anything strongly cemented below is gonna be considered a restricted layer. And we're gonna be talking about restricted and limiting on the next slide. Just letting you know that we're gonna be checking out those pads and we're gonna see how easily or how hard they break. And that's also gonna give us an idea, okay, does this soil, is it good for treatment? Does it permeate? So this will be another characteristic that we're gonna be looking at. So currently, when we do a profile hole, we are just looking for the limiting layer, right? The horizon condition that limits the treatment, limiting, restricting, groundwater, any of those could be limiting layers. Now, in this new regulation, we actually gonna differentiate those different terms, okay? So we do gonna have that limiting layer, where it's limited capability for treatment, but it can accept effluent. So let's think about a rock that actually can permeate really easy. But remember, treatment happens in the rock. In between the rock spaces, we have bacteria, we have water, we have air. So if it really permeates, it doesn't get treated. So that could be an issue. So we're thinking about rocky soils, fractured bedrock where just water flows and it doesn't get that time to be treated. One more click. Restrictive layer. This is the layer that restricts the vertical movement of effluent. Okay, so we have a very consolidated rock, something that it won't let the water flow through. Impervious bedrock, hard rock, clay soils, platy soils, items like that. And then one more. And now groundwater is separated. It's not a limited layer, it's not a restricted layer. Groundwater is the thing that we are trying to protect. That's where we want to stay away from, right? Okay. So table 10.1 was that table that we showed the first on how we design our STAs based on the type of rock. So if we can go ahead and click. Some of the changes is that we have different percentages of rocks, different classification for the rocky soils. Our soils are rocky soils. Rock is any component that is larger than 2 millimeters. So rock can be really small, just letting you know. And we also are adding new categories for this table, such as fractured bedrock and deteriorated bedrock that we also gonna be covering today. And we are, like I mentioned, this our soils, we're just gonna have different types of our soils depending on how cemented, how hard these soils are. Not just the type of soil, but also how it permeates water. Let's go. All right, so table 1A is very similar to table 1A, where we just have the soil types, but this is more about rocky soils, right? So if we can see those new additions up there, we can't really see it too much. FBR, fractured bedrock. The second one is deteriorated bedrock. Now we have our rocks from R0 to R3. This is very important for the designers. We used to have R1 types, different types of ours. Now it's just from R0 to R3, and then fracture and deteriorated. Okay. So these are some of the new ones. Fractured bedrock. Okay, we are looking at characteristics also, how easy or how hard is to excavate this rock. Okay, we're still using salt permeability as our main category here. Remember, we want to have some time. The water needs to stay some time in this rock to be treated. If it just flows through, it doesn't get treatment. If it stays too long, we're going to have accumulation. So we want to have that perfect MPI, that how fast this water percolates. Okay, so we have fracture, deteriorated, and then R0, which is soil type 1 is sand, but let's think about a hard sand that it has sedimentation in between. So it's not just that loose sand, but it's actually hard sand. All right, let's go for the next one. So let's think about fractured bedrock or new addition. Okay, we all seen hard rock. This is, straight up rock is fractured. Nature fractures these rocks. Okay, so how do rocks get breaking? Earth have some strengths, have some movements, it can break. Also, when the water falls in between the rocks and it freezes, it expands and it breaks the rock. So that's what we call mechanical breaking, right? So these rocks get fractured because of mechanical issues. So the spacings in between are called joints, and they're gonna be something important that we're gonna be noticing. So as I mentioned, it's highly fractured, so it disperses really quick. The water just flows through it. There's not enough time to treat it. So things that we're going to be looking at the fractured bedrock is how separate are these fractures? How separate are these joints? Why? Because the closer they are, it's easier for the water to percolate, right? It's faster flows. If we have these fractures really far apart, water needs to find these fractures. It's going to take longer to get them to actually percolate. So we are going to be determining the distance between fractures. If we have fractures less than 4 inches apart, you see there's a lot of vertical fractures, water is going to flow real quick. So it's going to be classified as soil type 1, like a sandy, because it's going to flow really well. Unlike, let's say, if fractures are more than 8 inches apart, water needs to find these fractures to flow vertical. So it's going to take longer. So it's going to be classified as soil type 4, like a clay, because it's just water is going to take longer to permeate through. Okay, and so in between. So that's how we're going to classify a rocky soil, a fractured bedrock, kind of similar to a soil type, just depending on how separate these fractures are, because that's how the water is going to percolate down. Let's go for the next one. Deteriorated bedrock, that's the other classification. So we have fracture. Now deteriorated is more about a chemical weathering. Okay, so when we have water sitting there, so this fractured bedrock gets some water, some chemical changes happen. We have silt and clay coming out of solution. So it looks kind of junky, okay? It's not just one piece of rock, but it has a lot of rock fragments. And it can change, it can vary, like it can look like soil, it can look like sand. Just want to be aware that probably bedrock is really similar. There's going to be a lot of rock fragments in between. The difference between this one and the previous rock is that now we're going to have more fines. So water is going to take longer. It's going to be some time for it to be treated. It's not just going to percolate. It's going to sit there. Sometimes it's going to sit too long. So let's go for the next. So for deteriorated bedrock, we're gonna be looking at how hard it is to excavate, okay? So we have low, when you can excavate with a shovel, up to extremely high, when even with a backhoe is gonna be tough, okay? The importance of this is that if you have a higher level of excavation difficulty, your soils are gonna bump up, okay? So let's say we have a soil type 1, sand, but it's really hard to dig. Depending on those parameters, we can treat this as a soil type, as a soil 2 or a soil 3, depending on how hard it is to excavate. Here in highlighted, it says that LTR must increase by the following. So if it's something moderate, you just jump 1. So from type 1 to type 2. If it's a high excavation difficulty, it's gonna jump 2. So let's say a soil 1 is gonna jump to a soil 3. And then it's gonna jump 3 soil types if it's very high or extremely high. So a soil type 1, a sand, can be treated as a soil type 3 up to a soil type 4, just depending on how well indurated, how hard it is to excavate. Okay, so that will be something to have in mind when we're designing. Okay, we're just not gonna look at the texture anymore. We're also gonna look at how well indurated it is, how hard it is to excavate. Because that's also gonna mean that the spaces in between are cemented, are filled, water's not gonna flow, we're gonna have issues dissipating and also treating this effluent.
Renee?
Yes.
One thing I like to note is, when you start getting to the high, the very high, at that point, I think it's really time to start looking for fracture.
Uh-huh.
Now it's probably more of a fracture bedrock instead of a deteriorated.
Yeah, it's gonna depend on if it's just homogeneous and solid, or if it's really fractured and deteriorated. So this deteriorating can release cement. So even though it's really well broken, it can be really tough as well. So
And, there's a gray area between deteriorated bedrock and fractured
exactly,
bedrock. And
to
it
be
does-
evaluated on site. But yeah, that's why we call it in situ fracture. It's not really dissolved, it's not broken apart. It's deteriorated, you can see more, there's pieces coming apart. So yeah, definitely that's something that needs to be evaluated on site. So, great talking point. All right, more R types. So remember, we have now from R0 to R3. So we can have different types of soil. It's just more about the rock components are gonna change, right? Small rocks, that's 2 millimeters or larger. So yeah, you can have different types of rocks there. Remember, soil permeabilities or parameters is highly variable. So rocky soils can permeate real quick, also can permeate really slow, okay? But then we also have excavation difficulty here. As you can see, the treatment levels, we're talking about the sand fill. How much sand we need to treat this. Because if water percolates real quick, we're gonna need more sand, right? Because we need to have this treatment. If this water doesn't percolate quick, we have enough time. We don't need such a thick layer of sand because we have the natural soil that's gonna do the work for us. This goes. All right, and R3, the same concept. Here in R3 is more about the excavation difficulty. Okay, so we're going really, again, we have a soil type between 2 and 4, but it's really hard to excavate. It's really tough. Water's not gonna permeate. We're gonna have issues. That's why even for TL1, treatment level number 1, we need at least 3 feet of sand because this rock is not permeable. It's not treating our wastewater enough. So that's kind of what I wanted to share with you guys. So it's not just looking at the texture of the soil anymore. It's also how well indurated it is, how it permeates, and then we also have some new rock classification. So we'll be talking about this more. So yeah, please keep your questions. I don't know if anyone has any questions right now, or we're just gonna keep them for our deep dive.
I have a question.
Yes.
So when you say difficulty of the excavation, that's all in like pre-design stage? Like when, at what point would that be deciphered?
That will be based on the profile hole excavation.
Okay, but is it the excavator operators, hey, this was really hard or this was really easy?
That's gonna be
How
a
do
great
you-
point.
How do you judge that?
We will definitely be relying upon excavators along, be like, hey, how'd it dig? Hey, this layer, how did that go? Like, we'll also have our tile spade and like, there are some like standards of how we evaluate that difficulty, but it will be a lot of how was it digging during that operation, that kind of stuff. When it pulled out, how did it pull out? Was it massive blocking? So there will be a little bit of back and forth between the engineer, the excavator, and us, which is really cool that we have that opportunity out here.
So a lot of evaluation on site. So yeah, like I mentioned, conversation. You need to let us know how hard does it feel? How much rock are we getting out? Once it's out, we look at it. So definitely a lot of moving parts there. Yes, sir.
I'd say like this got pretty deep into the design end, and most of the installers probably don't need to worry about like is it a sandy loam or a silty loam. But I'd say like be looking for changes. You see something not what you're expecting. Like if you dug the house foundation over here and it's all nice and sandy, and then you go to dig the field and it's rock or clay or something, call your designer.
Yes.
Like, hopefully we designed for that, but you know, we never know. Or I've seen one where, you know, you're digging the field along and it's nice and sandy and sandy and sandy, and then there's just a line in the middle and you hit clay. Like, you guys will know those changes. If you see something weird, if you see something change, if you see something you're not expecting, call your designer. Don't worry about it.
And as you mentioned, it's not just limiting anymore. We also have limiting, restrictive. Now we're going to be talking about groundwater, whether it's seasonal or it's just a water table. But yeah, we do have more parameters. And as Rob mentioned, the designer needs to account for all of these variables now.
Yeah, I think that's the main take home is just how does this apply to contractors? When you're digging a profile hole, every once in a while, we'll see variability from one side of the hole to the other side of the hole. Then you take that and extrapolate it to a 1,500 plus square foot soil treatment. If you guys are in tune with how the system was designed and the complexity of that, you're going to be able to help that homeowner have a successful system. Even use permit inspectors, you know, you're looking at a system that's 30, 40 years old, and maybe it wasn't appropriately designed. And now the owner's going, should I rehabilitate this system or should I rip and replace this system? You know, you're like, well, it was put in the clay and it was designed for a sand. I don't think there's any hope for this. So you guys are professionals, and I just think it's good to spend a little bit of time understanding the details of how systems are designed. So,
And
thanks,
that's
Trey.
also another parameter why we don't drive on top of STAs, because our texture will change, right? We're gonna cement, we're gonna compress, water is not gonna permeate anymore. Also, why we don't wanna leave STAs open during a whole winter season, because the water will dissolve these little particles and it's gonna create some kind of cement that is gonna also impede better absorption. So that's why we don't drive over STAs, and that's why we try not to leave an STA open for a season or two.
Cool, thanks. All right. So we'll kind of just wrap up the design portion of it by talking about mound systems aren't really changing that much in terms of their design. Our rules and regulations are actually becoming a lot more lenient when it comes to a higher level treatment system, followed by a sand system. You know, a sand system is TL3 technology, and you might have an Advantex TL3 technology at the tank. You don't get to compound those in the past. Now you will be able to really reduce the size of that bed. You can go to the next slide, please. I think we'll just kind of skip through this for the next session. Go ahead, next slide. Okay, so I think you guys will be, at least the contractors in the room, will be more interested in the rest of these slides. Thanks for bearing with us on some of the technical stuff there for designs. So the old regulation said you need to have a clean out within 5 feet of the house on a sewer line, right? So the new regulation is a little more lenient on that. Talks about a two-way clean out. That's new, right? We didn't specify two-way in the past. No smaller than the building sewer. There's another section that specifies 4-inch. Must be installed between the building and the septic tank as close as practical, but no further than 50 feet. So you're installing something and there's a deck there that you don't want to put a clean out underneath. You can put your clean out just beyond the deck. Next slide, please.
So Dan, on,
Yeah.
like tank replacements now, we have to put double sweeps in.
Yeah. I would say yes, but it also depends a little bit on how much work on the sewer line you're doing. If there's no clean out, you should put in a clean out there. Yeah, exactly. But yeah, in the past, that's been a question because you're nowhere within 5 feet of the house. Now you probably are within 50. That's a good point. That'll probably almost be 100%. you gotta
So
install.
just
a
moving
sewer
for
line.
a double sweep.
Yeah.
Tank replacement, if there's
Yeah.
not an existing.
Yeah, and the service providers in the room, what's the length of a sewer snake typically? 50 feet or, I'm sorry? 75, okay. But I think that was the intent of this 50 feet maybe. Yeah, Mark?
On the site you and I just looked at a few days ago, we talked about, you mentioned having to add a clean out downhill of the tank in between a gravity, an older gravity field and the tank. Does that require both doubles, two direction or just a downhill?
I don't know, I'll have to look that one up. Definitely still in there, Mark.
Okay.
Everybody hear the question, basically, if you've got an old style design, well, either a trickle feed to a field, you flush 2.5 gallons at the toilet, 2.5 gallons goes to the tank, 2.5 gallons goes to the field, right? We still see those occasionally. Our code, I don't even remember when that was put in, but it's been in there for a while. You gotta have a clean out downstream of the tank. Same with a siphon type system. Mark's question, if I heard you right, was does that need to be a double sweep? I don't remember exactly. When in doubt, throw it in maybe, but maybe Seth will find an answer in the meantime. So we talked about exam reciprocity, secondary tank containment devices. So your primary tank security device is the lid. All that's still in there as far as, I think it says at least 70 pounds weight or secured mechanically or something along those lines. But now they're requiring a secondary tank device. So you've got a riser, and then in that you'll have something kind of like this image here. Manufacturers make these, and they'll be required from here on out, or at least next week. Yeah. Yeah, it's worded to say your kids don't fall in, pets or wildlife. If you have a pet rat, I don't know that we can help you necessarily because this isn't going to protect from that. Yeah.
Does Valley Precast, Front Range Precast know about this, or do we, as contractors, need to inform them?
My responsibility is with the contractor, so I would say you should always double check with them. But I'm 99% sure they're in tune and they're going to try to sell you one of these that are now required.
They're aware, but there's gonna be a learning process, for sure.
New system installation, not retrofit, or is it just retrofit as well?
So let's say the question was if you're retrofitting a system, would we expect this to go in? That's a good question. If you're swapping out a tank, we would expect this to go in. If you're only swapping out the field, we would not expect this to go in. But it might be a good thing to throw in. Think about, okay, confession time. Who has bought their dad a septic tank filter for Father's Day? Anybody? Nobody? Come on. I think that's a good idea, and maybe if you're doing other work, you could ask them to upsell them for something like this, even if you're not messing with the tank.
Dan,
What's that?
Do we have to retro for title transfer instrument?
No. Just like a clean or a effluent filter is not required. If it wasn't required in the original construction, we wouldn't require these on a use permit inspection if it wasn't originally designed for it. Yeah. Has anybody worked with these much? I haven't.
Coming quick.
Yeah. Okay, next slide, please. This isn't a regulatory change. This is something that I wanted to bring up. We've seen a lot of what was it, Connor? We were looking at how many higher level treatment systems we've had recently, and it was like half of our systems were higher level treatment systems. Well, every higher level treatment system has to maintain an operating permit, a service and O&M contract for the life of the system. And so I just wanted to emphasize that higher level treatment, in my opinion, should not be the go-to, okay? Try to do a non-higher level treatment design first before you go to a higher level treatment design. Then you go to a higher level treatment design, get that approved. And if that still can't get you a conforming system, then you have to go to a variance. So a variance can only be considered once the designer has exhausted all opportunities for designing a system that doesn't require a variance. So when someone contacts me or the team and says, I need to get a variance, and I play pretty hard ball with the designer, why can't we do this? Why can't we? I'm not trying to be an asshole. That's part of my job. We're only supposed to process variances if all other options have been exhausted. Variances must always maximize the setback. So if the setback to from a soil treatment area to a well is 100 feet, don't submit a 80-foot design when you can get 90 feet. You always have to maximize that. And part of maximizing that is to do the highest treatment level possible. So TL3N, I think, will get you the smallest square footage. Matt,
So if the property line reduction to 3 foot is not a variance,
still to be determined. We're gonna look that up.
I got it. I was
Okay.
gonna bring it up when I talked, but yeah.
well, it
What's
affects
the
what I'm
answer?
about to say.
Oh, the answer is that is not Board of Health. Under 3 feet is.
Yeah, less than 3 feet.
Yep.
So, would you prefer we carve in with a property line setback instead of doing higher level treatment?
Good question.
I don't know. I'll have to think about that.
Well, it's a no operating permit for you to follow up on.
I think I'd rather see the higher level treatment, just thinking out loud
I mean, that's
offhand.
where I
Because
would
we're,
answer.
the part that talks about how you can't encroach on your neighbor's ability to develop makes me nervous.
What if you encroach on them and the neighbor has to, build a treatment system,
Well,
that's their problem.
and one of the parts is you can't put in a conforming system
Build first.
to get the 3 feet. And so if you can demonstrate that you can put in a conforming system utilizing high level treatment and not have to go to the 3 foot, then you wouldn't be able to utilize that reduction. It has to be one that you can't have a reduction or a conforming system on that.
Yeah, I'd have to read that language again very carefully, but I think we would push for higher level treatment before allowing an encroachment on a property line. Maybe that's just because it's new. I don't know. I'll probably get more comfortable eventually, but I could see that being a civil lawsuit pretty quickly down the road, maybe. And I don't know about you guys, I don't like lawsuits. What's that?
Would the well distance matter then, you think? Cause, I mean, if you were further, the well was further away and you could get away with it, but if you're,
Yeah, I mean, let's say that neighboring property is already developed.
yeah.
And their well is 150 feet away. I think that's an easier decision than an undeveloped parcel in Heaney on a 1/10 of an acre. You're always gonna have encroachment there. So, yeah. I don't, claim to have all the answers. Some of this we're gonna just kind of explore as we're going along and hopefully create a little more standard as we go. For repairs within setbacks, variance conditions will be applied. So I think Seth talked about this a little bit. You've got a failed system that is 80 feet from the on-site well. We can generally approve a replacement system that is also 80 feet or more to that well without going to the Board of Health. Same with like a tank setback also. But we will still require higher level treatment, all the same variance conditions. All right, what do we got here? I didn't make this slide. Vertical separation and infiltrative surfaces. I think this is just talking about our TL3 and D versus TL3, Seth.
So most important part, I'm sure y'all have all giving you the good news of we need way more sand to bring this up. And you're like, why would we ever need more sand? There's already 8 feet of sand here. And you're like, well, we need the separation at a certain elevation. I ran the elevation, it's not that. That's not what we're getting at. As you can see, we did a profile hole, right? We saw groundwater at 2.5 feet from ground surface. We need to protect separation of 3 feet down from 2.5 feet at native ground surface. So you could build that up 8 feet, we need that separation there. You can take it down 2 feet, we still need separation from that exact point. So always check your permit because it'll say something like must be 6 inches above grade. to meet your 3 feet to that groundwater. So it doesn't matter what the surrounding level will be, what you want to take down from around, what you want to build back up around. We need to take it from where we saw it at that native elevation. And that's why it's really important to check those permit conditions as to what elevation and separation you're looking at, where to put the bottom of the rock. That's the worst news we have to give folks, and it's all too common. The misconceptions are out there, and well, we're just going to grade down. So no, always look at that. If the elevation's wrong from your design, go back to your engineer. But what we're looking at is from that native grade is what the elevation and infiltrative surface is being based on.
So again, this is always a permit condition. If you flip to the back of your permit, it'll say, either the field needs to be this far above original grade or maximum of this far below. It's not just filling words on a page. It's a very critical requirement. So. Pressure rated pipe and fittings. This was a picture from someone recently. I forget exactly who. Oh yeah.
Years ago.
Yeah. Thanks, Kyle. Always appreciate photos. Where a non-pressure rated fitting was used on what should be a pressure rated fitting. Those overlap more, so the glue has a lot better opportunity to hold in the long term. And so we're not making up and just trying to cause trouble when we fail these things in the field. And the better you guys catch, the less we have to catch, because we're not 100% either. So, all right, next. Ooh, liners. So these aren't reg changes, but these are just meant to be issues that are challenging. Man, I've seen some of the work you guys do on retaining walls. Yes, I do get out of the office now and then. Dave, yours takes the prize for sure up there. Retaining walls are really tough to build. I would encourage you guys, when you're doing a lot of them, just talk with us a lot, because we can't hold you up to inspect every piece of that liner going in. And so between pictures and us coming to see certain parts of it, I think we can get to, an appropriate balance there. Anything you wanted to add on that?
No, on this one, you can kind of see where the field is. So just always think about it in that vertical horizon, that you want to be 6 inches below where the field is, and kind of key it into native, fold it back so it stays upright, and then build your wall or liner off of that. So it's kind of a nice just visual representation of, like, if you're thinking about a ditch or the field, just get 6 inches below that more limiting portion. That's where you're going to start.
Next slide. Tanks must be set level. What was the question? How level?
That is
our
often a question we get in the field is
acceptable
how
tolerance?
level.
Yeah, I know it's tough. I know it's tough.
2 directions.
But tanks are designed to operate when they're level. And so, I think what we've kind of informally talked about is the bubble should be between the lines. I rarely have failed tanks, but we've seen more out of level lately. And so try not to slack on that. Don't slack on that. Abandonment. So our regulations don't really require any abandonment process for a soil treatment area. Some people like to excavate the soil treatment area, take it to the landfill, whatever. That's fine. But we do have very defined requirements for abandoning a tank. The primary concern is it's a void in the ground. You don't want someone to fall in that later, right? Also, you obviously need to pump it. So you want to call, get it pumped, and then you can either crush it in place and bury it. You can haul it off to the landfill, which probably happens a lot with plastic and fiberglass and metal tanks, or you can leave it intact, punch a hole in the bottom, and fill it with a non-compactable material like 3D or sand or something along those lines. And then send us a record of that, the pumping receipt, and just a note on how you abandoned that. Why? I'd say the main reason is we notify the clerk and recorder's office that this property is now served by sewer rather than septic. So that's helpful, especially at point of sale use permits. Okay, oh boy, I can't even read this one. Plans and permit on site. Okay, next slide. Any questions? Have your plans and permit on site. I think this last little condition here too, in case sewer, if within 50 feet of wetlands, tanks shall be moved east to maintain 50 from wetlands and maintain 10 feet to property line. You don't need to memorize that. It'll be on your permit if it's applicable. We only put these permit conditions on the back of your permit that apply to the site. There are a lot of setbacks, but we don't put them all on the back side of the page. If the well's 200 feet away, that may be important in Park County, but it's not important here. We usually won't put that on the permit. But if it's 101.5 feet away, we'll put it as a condition on the back to pay extra special attention to. Pro tip, the inspector is usually going to be referencing this list as well. So you better make sure that those are all compliant. So, okay. Final inspection. That means we're getting close to the end of the presentation, right? Yes. Okay, a new reg change is leave the little caps that go in the squirt height in the end cap. So the little caps that you screw in that have the 3/16 hole or whatever, and you usually take with you, right? We want you to leave those now. The reason is there can be a lot of good diagnostic tools for those of you guys that are doing use permit inspections. Okay, the squirt height was 6 feet on all of these distribution laterals 10 years ago. 5 years ago, they were at 2 feet. And this year, one of them squirting 20 and the other ones aren't even getting to the surface, right? So it's good to leave those little plugs in there. The PE who gives the final approval letter, the regs ask for you to document the squirt height. We've also talked in some of the NOT trainings about documenting it on the inside of the control panel. I know there's not much room there, but it's just really useful information in the long term. And then note elapsed time and event count as well. Next steps. So 2018 regulation is effective for 1 more week, right? So the way we've always done it in the past is you get your designs in prior to that date. We apply the old regulation. So you guys are going to be installing systems under the 2018 regulation for up to a year, right? And so following those permit conditions and the approved design, which I think I glazed over, make sure with your permit you've got the approved stamped design on site. So you're going to go, well, hey, there's a secondary tank containment device required, I think. I got to get one. I hate to tell you, you can take a pass on that, but if it was permitted under the old regulation, you can take a pass on that. Does that make sense? That's pretty standard the way we've always done them in the past. Again, for contractors, it doesn't matter much. You're just installing what's permitted, what's approved. So starting on May 11th, the new regulation is effective. Permits issued under the 2018 will be honored until the expiration date. So that's going to be a challenge. We've got about 50 permits that just get reissued, renewed. No intention to build. You guys may or may not know that. Well, if we're going to be issuing a permit next month, that permit and that design needs to honor the regulations in effect at the time. So any permit that is expiring and is not, commenced construction will have to be looked at by the design engineer to make sure that it meets current code. And that may require new soil profile holes because, as Renee mentioned, and you guys were just so thrilled to be engaged in the new soil changes, there's a lot. And so if we can't confirm that soil out there wasn't cemented or fractured bedrock, we may have to look at a new soil profile hole. We had this in 2014 as well, when some of the soil stuff changed. That's it. Next slide, please. Oh, we talked about the fees. That's my AI generated. That's not a real red line of a design, of course. $126 for the homeowner that wants to bump from a 4-bedroom to a 6-bedroom, and $63 for a pre-permitting type revision, where we're going back and forth typically with the designer to get it permittable. And again, one complimentary revision will be included with the permit fee. Next slide. Oh boy, use permit inspectors in the room. Don't be shy. This is just for you primarily. So there's been a lot of talk with NOT, the National Association of Wastewater Transporters, about changing their inspection criteria to include what's called the dry aggregate rule and the hydraulic load test. So these are very invasive and potentially costly evaluations of a septic field, a soil treatment area that involves putting a day's worth of flow into the soil treatment area, coming back the next day to kind of see how much the water level has dropped, to basically see is the soil treatment area capable of accepting a day's worth of flow, right? You can imagine on some sites, the other part of that is the dry aggregate rule. A lot of this will involve digging down into the soil treatment area, especially if there aren't observation ports in place, to actually see where the water level is. You can imagine how challenging that would be on some of our sites. It's going to be challenging on every site. It's pretty much the standard in Pennsylvania. It's prohibited in New Jersey, Virginia, thank you. Maybe in New Jersey too. I don't know.
Supported highly in New Jersey.
Supported in New Jersey, okay. And NOT was more or less saying this is going to be mandatory for our inspections. So CPAL regulators have gone back and forth with them, and they're kind of backing off of that. We require a NOT certification or similar. We don't require a NOT inspection, okay? Inspections are to be done on our form. We try to mimic that inspection form to look like the NOT inspection form and the NOT criteria, but NOT doesn't set, here we go, I'm on my policy soapbox. NOT does not set policy. You know, the Board of Health does, the State Water Quality Control Commission does. So we've done a lot of negotiations on this. Like, if we require this, our decision makers, our Board of Commissioners are going to say no more use permit inspections, because these are going to be cost prohibitive, right? Maybe an owner will want to pursue this. I would support it if they do, but it's going to take our use permit inspections from, I'm just throwing out numbers, $1,000 to $4,000 or $5,000 on some of these sites. So we're basically putting our foot down saying, no, we are not going to require these. And we are talking about maintaining the operations and the dose test. NOT has been backing away from this, oddly enough. This is where you apply one dose to the soil treatment area and see, you know, if it accepts it like we've always done. And NOT has kind of not promoted that for a few years. We're going to continue to promote that as kind of a balance point between this dry aggregate rule hydraulic load test and doing nothing at all to test your field. So we'll be revising our forms. There's a statewide work group that is really working hard to come up with a standard use permit inspection form across the state. So hopefully, again, that'll help some of you that are operating in multiple counties. Next slide. I swear, I think we're almost done. Okay, our friends in the engineering department, this is a shout out for them. We're seeing it a lot this year where we're getting a call for an inspection and we see that there's no G&E permit issued yet. That G&E permit is supposed to be acquired before you start doing site work. Seems duplicative, right? Environmental health is issuing a permit. You also got to get an engineering permit. The only thing I can say is there are different regulations. Yes, we're both part of the county, but we have different interests in some of these things. One of them is floodway areas, South 40 down there. They've got a lot of floodplain areas. I'm not an expert in that, engineering is. They also require like the erosion control. You guys know this. I just want to emphasize, when you apply for our permit, if you have intent to build, come upstairs and apply for an engineering permit, or they prefer that you just submit an email because they're a small department, they're not always staffed. So if they're not here, just submit an email to engineering@summitcountyco.gov and take care of that. Okay, I think this is honestly the last slide. We have our information here on our website. You can get our old regulations, new regulations, that summary of changes, all on our website. I think most of you have been there. You can also get any as-built for any neighboring properties. All the designers know this. So utilize our website. And if you have any questions, I've got Seth and my email up there. Most of you have it. Don't ever hesitate to reach out, or by phone. That's Connor's main line, our office main line. Definitely better to always, communicate and reach out if you have any challenging situations. So this slide is here for our friends that are currently sunbathing on a beach in Florida and can't be with us today for whatever reason. What we're going to have them do is they'll get to this last slide and they'll see this QR code, they'll scan it, and they'll go to a little Google Doc type sheet where they can kind of sign an affidavit that says that they participated and are as smart as all of us. So, any questions? Yeah.
Has Summit County always required Schedule 40 going in and out of the tank?